Greetings, everyone. Welcome back to BSides 2026 here in Las Vegas. RVL Srivatsa is a security engineer at Amazon working on application security and the security of AI and machine learning systems. He has a wealth of knowledge in independent research, but today we're going to be talking about rejected input programming. Please meet Mr. Srivatsa.
Thank you. All right, welcome everyone. Thank you for attending. Welcome to the last day of Besides Las Vegas, early morning, I guess. This is the first session of today. All right, so let's get started. Good morning again. So, 8 files. Every one of them rejected by the parser. The parser was not confused. It was not bypassed. It was not broken. It did not have a bug. It read each file as it was supposed to read and found the problem, returned the error correctly. 8 out of 8 times. At the end of those 8 rejections, I owned a function pointer in the running process. The gap between a parser correctly saying no and the process actually being reverted to a safe state or the unchanged state is the whole talk. My name is Srivatsa, and this is Rejected Input Programming. 30 seconds of context, real quick. My name is Srivatsa. As was introduced, my day job is application security engineer. I mostly focus on AI applications, AI products at Amazon, working in specialized business securities. My background that matters here is the one before that. I came up doing low-level work like kernel exploitation, binary exploitation, memory corruption, reverse engineering. Nearly did a PhD in the kernel security instead of taking a job. But yeah, this is the lens I still read the code with, which is the low-level stuff. And this is why this talk is about a struct and a mem copy instead of a web framework, if you will. More recently, my research has been in the AI/ML infrastructure because that is where a lot of unreviewed native code has been. One of those is the unauthenticated RCE in Langflow, which a couple of you might have heard. It was in it got into the CISA known exploited catalog within 20 hours of being exploited. The same bug is, by the way, up for a Pony Award at the DEF CON. So yeah. So I mention it for one reason, that later I'll show you a survey where I read 15 top most used parsers in the code bases by hand. I want you to know what kind of eyes were on that code and how did I recognize that pattern. So yeah, let's get started. When a parser rejects input, every layer of our stack treats it differently. Every layer of our stack treats that as a failed attack. The WAF sees a blocked request, nothing to log at severity. The parser author says that I returned an error, so therefore nothing, I returned an error, that is my contract, and the caller can handle later. The caller says it returned an error, so obviously nothing was applied. And the reviewer sees the error path returns early and says it looks fine, right? Now, notice, nobody in the chain actually is wrong. All of them, every one of them is individually true and reasonable. If you'll audit any one of them in isolation, you won't find anything. But nobody rolled the state back, right? Every one of them assumed someone else did it. So if I'll ask you how many of you have written a config loader or a policy loader, anything that takes a file and populates a struct, a lot of you might have for an enterprise grade application or even for your open source projects. But how many of you are certain that the one you wrote actually rolls back cleanly when it hits a syntax error? That is what this talk will be about. So before I show you anything, I want to draw a clear line around what is new and what is not. On the left is the work this stands on, langsec. Input is a language parser. Input is a language, parsers are the recognizers. mix recognition and computation, and you get weird machines. Shotgun parsers says validation smeared through business logic, weird machines, crafted input driving an unintended state machine already inside your process. And the atomic parsing, which is the existing guidance around parsers to stage and commit only after validation. This is not my idea either. And I hand it back to you at the end of the fix. So if you know that literature, nothing on the left surprised you. And I'm not claiming any of that is mine. So here is the line that I'm not claiming again, is that parser mutates state before rejection. That is known, everyone knows that. It's written down, it's a hygiene item for years. What I'm claiming is this. Rejected inputs are chainable. Byte, granular, write, primitive against the application state. Chainable means that one rejected input is not the end of it. They accumulate. And from an offensive security point of view, anything that accumulates can be chainable. So byte granular, meaning I pick the offset and I pick the value against a live state, meaning the object the process is actually using. Prior work looks at this and says, just avoid it. It's an hygiene thing. I'm not looking at the same pattern and saying I can drive it. That reframe is the whole contribution. Smallest thing I could write that has real shape, a service struct, 16 bytes of banner, then a function pointer, the handler, then a mode flag. Yes. The handler sits at the offset 16. So remember that because that is our objective. Underneath, the loader, the magic header, then records saying write this many bytes at this offset, then a checksum over the whole file, a completely normal format, 3 lines in this order. So if you look at the bounce check, offset plus length has to fit inside the struct. It is correct, right? And sit with that because this is why this survives reviews. You see a mem CPY, your eyes goes looking for the bounce check and it is right there and it is right. So you approve it, I would approve it, anyone would approve it. Second, the destination, ampersand SVC, that is the live object. The struct, the running process is using right now, not a copy. Now at the end is the checksum, the thing that decides accept or reject. It runs after the loop, after every record that has already been applied. So by the time this function decides your files, if your file is garbage, it has already written bytes into your live state. So the bug is not memcpy, it is the bounce check. The bug is not the checksum, it catches every bad file. The bug is the order, right? So let's use it. Here is exactly what I'm about to run. So pointer is 8 bytes. I want to write 8 specific bytes into the handler slot at the offset 16. Remember that was our objective. So I build 8 files. Each file carries our record. It carries one record, 1 byte, aimed at the handler slot plus I. File 0 writes byte 0 of my target address. File 1 writes the byte 1 up to 7. And every one of them ends with a checksum, which I got wrong on purpose. I want to be clear about this because it is what makes this interesting rather than boring. I'm not sneaking a valid pass, a valid file past the checksum. I'm not trying to bypass it. I'm not trying to forge the checksum. I could not, and I do not need to. Every file is going through all the checks and all the functions, and at the end it is going to be rejected, and that is the design. 8 rejected files, 8 bytes in order spelling out to a pointer. That is the whole exploit. 2 lines, build a patch aimed at slot plus I carrying byte. hand it to the loader, which gets it rejected, and repeat it same 8 times. So when I run this, 2 things to watch. One, the return codes. Every one will be a -4. Two, the very last line. That is it. So let's run this in the terminal. This is a not a real-time tag, but yeah, recording. So what happened? What just happened? 8 files went in. The loader rejected all the 8 as it was supposed to. It returned -4 correctly. Every time there is no bug in this rejection logic. And the function pointer is now pointing to somewhere where I chose. Let me walk back through and why that worked. Because every step was the code behaving correctly, right? 8 files, all these 8 files are the loader doing its job. -4 is the rejection code. Every file checked, every file was found invalid, and every file was rejected again. So if you were reading logs this morning, you would see 8 rejected uploads and think your validation was working. And it was working indeed, it's not sarcasm. So why did the pointer move? The bounce check passed 1 byte at offset 16 fits comfortably inside the struct. There was nothing to object to it, nothing to object to. It was never the thing standing between that and the pointer. The memcpy ran into the live struct. It's not a copy. So that write is permanent as far as the process is concerned. And only then the checksum failed and the loader returned an error about it. So if you look at the last line, the return code -4, which means the pointer moved correctly, both true, same function calls. So what this concludes basically is that rejection is not rollback. Two different properties most of our code has the first and quietly assumes the second. Now the same 8 files against a loader, that stages, right? So identical input, byte for byte, the same 8 files, same wrong checksum, same 8 rejections, same -4, and the handler never moves. Look at what actually changed, because it is smaller than the people expect. I did not add a check. I did not sanitize anything, did not touch the validation logic. The checksum test is character for character identical. So nothing is changed in this. The only thing that's changed is where this byte was, where the byte land. The memcpy targets the staged copy instead of the original live state one. Validation runs against the complete file and the commit. That one assignment at the bottom is only happens if validation passed. So if it did not, the staged copy is again, it's discarded and the live object was never touched. So we are not touching anything live object like we touched last time, but it's all staged, but it's still character by character same. Same inputs, same rejection, different landing zones. And I'm showing you this at this minute because for a reveal deliberately. Half of you are defenders, half of you are offensive security people. You do not need like maybe 15 more minutes of me breaking things before you are told on what to do. You have it now, and the rest is me showing you what is worth adding. So fine, you say that, okay, you wrote a vulnerable loader and then you exploited your own vulnerable loader. Congratulations. But that's really not it. Let me explain. So this is fair. So does the primitive travel? 4 target families. I'm going to read this through because it's very, let me see, the policy loader roughly that I showed you, a binary TLV protocol parser, the shape you see through network code, an archive index loader, a plugin manifest loader you see through the network, different formats, binaries, text, streaming and buffered, bypassed, everything is bypassed. So the primitive did not care what the format was. What it did, what it did care about is that three conditions. If you write down one thing today, make it this. First, partial commit. State gets returned during the parse, not after. Second, final rejection. Acceptability is decided at the end after those writes. Three is no rollback. The error path returns but does not restore or discard the original state. All three and it works, right? Miss any one and it does not parse. Partial commit, but you reject before it writes, so you are fine. Partial commit and late rejection, but the error path cleans up, still you are fine. It needs all three to work, so it's not a conjunction, it's not a checklist. It's not a checklist where you put 2 out of 3 and you can stop worrying. So let me show you this, the staged one. This is the whole suite end-to-end, 4 synthetic families. This is a minimal proof of concept, and then the 3 real parser binaries from a clean build. Yep. Synthetic targets are still again my code. So real ones, 3 parser libraries, unmodified, wired up the way people actually wire them up. It's an enormous number of C projects where this is being used. XPath, the SAX, XML parser, in more software than you would believe. It's being used. It has been for 20 years, and libyaml. So what most C and C++ reaches for to read the YAML today. I did not patch any of them. I pulled them as the ship and wrote the harness, the way the documentation which was provided, the official documentation, and bundled the example to tell you. The callback style, the parser hands you each key and value as it finds them. You write them into your own config as they arrive. And this is not me being unfair. This is a documented usage. So privileged hook reached, what does that mean? Privileged hook reached in every time. And now the line above each, which is INIH returned line 12, is telling me precisely which line exactly, which line was malformed. XPath return error 3, libyaml returned parse OK equals 0. Every one of those parser dedicated the malformed input and reported it accurately. There is no parser bug anywhere on this slide. So this is not a claim that INIH or libyaml are vulnerable. That vulnerability is an integration pattern mutating trusted state before an input has been fully accepted. So I want that on recording. I know it's being recorded. A lot of people are attending it live. These are 3 pieces of infrastructure. A large amount of the software in this room depends on, maintained largely by volunteers. They do not deserve a bad news cycle because I gave a talk. The libraries are fine. What I am attacking is the code between the library and your application state. That code is ours. So this is the pattern, something I constructed to have a talk, or is it what people write? So I went and read topmost 15 C++ projects integrating callbacks or event style parsers, real project people use. They run in production. Here is exactly what I did. So I read the parser call site and the error handling around it by hand. I counted direct mutation where callbacks wrote into the caller-owned state or the global config or an input object before the input was fully acceptable. And I counted no obvious rollbacks, only where the error path I inspected did not clearly restore or discard what has been written. 11 of 15 mutated directly. 9 of those showed no obvious rollbacks on the path I looked at. And before anyone asks, before anyone asks about selection bias, let me get ahead of it. 2 projects got it right, and I want to set that out route that not everything is super vulnerable to this, but I'll come to it. 4 more were inconclusive. Not sure if it's present here, but I have it in here. So 4 were inconclusive. I could not tell from the path I read, so I did not count them. And to be precise, this is a pattern survey, not an individual per project vulnerability analysis that I did. So matching the pattern is not about same as being exploitable, right? And I'm not going to imply that it is. But 11 out of 15 is not a coincidence. This is not 15 people or independently making a mistake. This is a pattern. This is the default thing that you write when you follow the documentation. One more, and this is not synthetic. A YAML config loader out of a real active public code base, widely used. Ordinary code, the kind of a function everyone in this room has written probably. The input sets a port, it sets an IPC name, and further down, there's a syntax error and unterminated list. So the parser catches it, failed to parse YAML, it did not expected a comma or a bracket. So correct error, accurate messaging, and now the line underneath. So return code -1, port equals 42.424, IPC names equals is attacker controlled. So there are on the same line, and those are on the same line, and this is the whole thing. The function actually told the truth. It returned an error, and it meant it, and it kept my port number anyway. So now think about the caller. It checks and returns values, sees -1, takes the error branch, maybe logs something, maybe it doesn't, and that config object is still sitting inside the memory holding those values. So whether that matters dependent on what happens next. In a lot of projects, in real code, what happens next is somebody uses the config anyways, because the load failed, it failed safely, and the defaults were obviously still in the place. So callers read returned an error as nothing was applied. That inference is the entire bug class, not just this function, not just this project. That inference, which all of us makes dozens of time every day. So this was a finding. It's still reported, but yeah. So let's come down to fix before I tell you everything. So the fix is generally not complicated, whether this is either reassuring or annoying depending on how much of your code base this applies to. So first is initialize a staged copy, never hand the parser your live object. Second is apply every parser event to that copy, and the callbacks never see the real thing. Make sure the callback never sees the real thing. And 3 is to validate the final full input, syntax, semantic invariance, end-to-end on the complete document. 4, commit only after success. 1 assignment at the very end. 5, on error, destroy the staged state and walk away. Live state was never touched, so there is nothing to roll back. Rollback is more difficult than to never have anything to roll back to, and that is the point. So rollback is something you will have to get right. Never having anything returned to is free. So to close where I started, rejected input is not a failed attack, it's an exploitation interface. The primitive is that rejected inputs chained into byte granular writes against live application state. The conditions, partial commit, final rejection, and no rollback. All 3 of it does not, or it does not travel. So the conditions and the stage fix is stage, validate, commit, 1 strict copy, and 1 assignment. That's it. So your parser returns an error. It is not the same thing at your parser leaving your state alone. It still wrote something, but it's still rejected. So those are two different properties, and most of our code only has the very first one. So before I end this, I want to tell that this vulnerability exists in a lot of parsers. This slide is not updated, but I've been doing this research like right till yesterday night. You will find this vulnerability in a lot of parsers. But the thing is why I'm not reporting it and dropping this on stage is because they are not exploitable. Being vulnerable and exploitable are not the same thing. Each of those parsers have something downstream or upstream actually helping them to keep themselves safe from this particular bug. That's why it's not exploitable, but it's still vulnerable. Now that thing that is preventing them, whether it's upstream or downstream, from being exploited, that thing is not designed to do that. That thing doesn't even know that it is doing that. And because it's not the use case, that thing might stop doing that in the very next update. So all those parsers are safe just based out of pure luck. Problem with luck is that it might run out, or someone like an attacker can have an even luckier day than those parsers. So yeah, that's pretty much it. Thank you so much for attending. If you have any questions, I think we have 5 minutes.
Questions?
Please raise your hand so that he can bring the mic to you.
Thanks for the presentation. Would you mind going back to the bounds check and helping those who are new to C and C++ understand how the privileged hook is reached?
Yep. What was your question again?
Would you mind helping people understand why state has changed? I understand that if people in the room may not understand it. Bounds check?
Stage is changed because bounce check, it only checks because it's a live state, live object. It only it is implied to do that. This is what happens every time. It is not a bug again. That's how just the bounce check works. Like it writes and then the checksum hits. That's how the bound works. Like it is supposed to do that. It's not a bug. Every time you do this, it actually happens. It's not a bug. Yeah, it happens. It's the right thing to do. Like that's how the bound works.
Time for one more.
I'll be here after, so if
All
you're
right,
out
thanks,
of
Mr.
time.
Srivastava.
All right, thank you so much. Hey.
Hello, everyone. Oh, okay. There's no sound. Never mind that. I have one question for you guys. You know what is the question? Who let the dogs out? Who let the dogs out? Okay. So, I am also a security researcher at Reflectis, and today's talk is Who Let the Dogs Out? This is an offensive research, real exposed Apache Airflow instances I found in the wild. Also, I deleted some of the slides after attending SkyTalks, plus new findings, including one CVE verified on Apache Airflow 3.x, and one more in the oven, which I cannot talk about today because there is no a new release yet. So I forgot to put my thumbs up. So let's get into it. Closer to the microphone. Maybe I should take the microphone. Yeah, I think it's better. Then I can move. I have the tendency to move. Can you hear me? Oh, now it's better. Okay. So here's the premise of this whole talk. If you just want to leave, all of you. Everyone runs Apache Airflow. Almost, but nobody treats it like what it is. So now, if you want to go, you can go. But stay. So there are four, okay, you can go, but stay, you can go, okay. So 4 parts. 1, meet Apache Airflow, what it is, how it's built, and how widely it's used. 2, exploitations in the wild. The wild, wild dag. And 3, the vulnerabilities themselves. Vulnerable code patterns, live demos, and CV I found in 3.x. In the next talk, we'll have also another one. Stay tuned. And 4, how to mitigate. The patterns to avoid, and how to get onto a current supported 3.x. Okay. So what is Apache Airflow? Apache Airflow, it's an open source orchestrator that schedule and runs data pipelines, workflows made of Python tasks. It's not the only options. There are others like Daxter, Perfect, Mage, and many others. But Airflow remains the de facto standard for Python-based orchestration, with by far widest production installed base and the largest ecosystem of maintained provider integrations. People run it for moving and transforming data, like copying last night orders into analyst warehouse, for machine learning pipelines, and for a lot of other heavy processes. For me, it was my thesis. And my work is about fine-tuning LLM for secure code generation. And when I say LLMs, it's not ChatGPT, OpenAI, or something like this. I mean for models that we have on premise for organizations that worry of privacy. So I decided to use Apache Airflow, and this is how the story begins. Okay. Something that is really, really important. The credit where it's due. You might think that I have a lot of criticism about Apache Airflow. This is not true. It's just about hardening. I appreciate the Apache Airflow team very much. I appreciate the developers. I appreciate the security team. They do a wonderful job. Remember, this is an open source. People don't get paid for this product. So there is a lot of things to make it better, but it's still an excellent product. So I really appreciate them, and now we can go on. So how it's built. We have a DAG, directed acyclic graph. It holds tasks, order, dependencies, schedule. The web UI and the REST API are internet-facing. That's the front door. The scheduler decides what runs and when, and the metadata DB holds connections, variables, and secrets. The workers actually run your Python. They read secrets. And every time I say secrets in this talk, please make some noises. You can say how, you can say who, you can say DAGs, you can do whatever you want. Please make a noise when I say secret. So let's try. I'll say it again. This is not a scheduler. It's a production control plane. Every box on this diagram is an attack surface. So how widely it's used? We have 45,000 plus GitHub stars, 16,000 plus forks, and the fork count is the tail. That's organization taking this code base in-house, real production adoption, not casual interest. 20 million plus PyPy pulls a month, 10,000 plus organizations, but a total are just the setup. The version distribution is the actual story. This is real PyPy data. 55% still on 2.x, 44% on 3.x, a few 1.x, not so much. So why are they staying behind? Why are they staying behind? This is the question. So Airflow 3 moved the goalpost to answer that. It replaced direct worker to database access with new task execution API and split the monolithic web server into a separate API server and DAG processor. On 2.x, the worker reaches the database directly. We don't like that. It holds the fernet key and every credential. On 3.x, an API server sits in between. Workers talk to it over a short-lived JOT without any database credentials. That's generally relocated the risk, but it created a new boundary. The workers to API server JOT handshake, okay? And we enjoy here of 403, 404, 405 reports. And one thing is unchanged either way. Salary executor still needs a Redis or RabbitMQ broker in the middle. This split is the fault line. So you can see the issues in GitHub, and I'm not going to read every row. The point is the pattern. 5 separate bug reports across every Airflow 3 deployment style. Compose, Helm, Kubernetes, all the same root. After upgrading, the worker cannot authenticate to the new API server, so its tasks silently stop running. 405 in May of last year, 404 on a subpath ingress, 403. You got the idea. And my personal story is I was lucky to get some budget from Google for Startups because I thought it's going to be a product that I will sell. But I'm not such a very good businesswoman, so I didn't succeed with this thing. But I installed Apache Airflow to create my pipeline of fine-tuning LLMs for secure code generation. And I used the ready-to-use Apache Airflow instance in GCP. So instead of just installing Apache Airflow, you can take it and use it. Until I realized it eats $1,000 for a month for this ready-to-use Apache Airflow, and I said, oh my gosh, I only have $25,000. It's not so much if you want to fine-tune LLMs. So I will excuse myself, and I will install the Apache Airflow by myself. So, of course, I'm a security professional. So I will install Apache Airflow 3.x, for sure. After a week struggling, I realized, 25 or 30 years in the industry as a software developer, technical support, developer team leader, security professional, pen testing. After a week struggling, I realized that maybe it's not my fault. With my background, I cannot install Apache Airflow 3.x, maybe the problem is somewhere else. And these guys in GitHub, they encourage me. And it's not the only problem. There is another problem. The worker to API server execution API defaults to plain text on port 8080. And it carries connections, variables, XCOM, task state, and the JOT bearer itself. TLS is opt-in, manual, and as I will show you in a second, historically buggy. Execution API, encrypted by default? No. Salary broker? No. Metadata DB? Not encrypted. And I have to say something, like, again, I don't want to put a lot of pressure on the Apache Airflow team because it's difficult. Did you try to put CLS on your production environment? It's very difficult. So if you want to do it in a way that other will enjoy it, like in a general way, because there are a lot of variation in the installation of Apache Airflow. Sometimes it's Kubernetes, sometimes it's K8, sometimes it's on-premise, sometimes. So to make it to help it to work in a general way, it's very difficult. So I understand why the responsibility for the TLS is for the one who installed Apache Airflow. Okay. So people try to turn on TLS, and here's what happened. Docker plus a self-signed cert, web GUI is fine, but the worker to API runs fail with a certificate verify error. 3 months later, the same failure gets reported again independently. The Task SDK HTTP client does not pick up the CA bundle. On the salary side, Redis Sentinel SSL is rejected outright. The secure Redis scheme falls back to the insecure one with a warning that's very easy to miss. So real partial fixes did ship, and credit is due for that. But still, there are a lot of bugs, and it's very difficult to implement TLS. So we covered what Apache Airflow is. We mentioned some problems about moving to Apache Airflow 3.x. And now, let's see what the wild eggs. This is a showdown query, and you can see here, I think Apache Airflow 1.x. This query is for the DAG last page on title with no login, and this is the default on Apache Airflow 1.x. since 2.x forces the sign-in page first. So it's either Apache 1.x, or it's someone that really likes to shoot himself in the leg and turn off the authentication module. So I assume it's 1.x. So there are a couple, if you strip the honeypots and just exercises for OSINT students, you get a couple of instances, but the number is small, but it doesn't mean safe, because these are real boxes. And this is one I want to tell you about. So the first one, this box variable store ends back a QuickBook OAuth application client secret. Woo! Secret. Roof! And roof, roof. Application client secret and refresh token in plain text, no authentication needed. That pair means fresh hour-long access tokens for about 100 days. What can go wrong? Full read-write on the company books, invoices, customers, bank transaction, and this is Apache Airflow 1.x, end of life on 2021. And I saw there also Apache Airflow variables that are not in a secret manager. And I'll say it again. Secrets, woo, woof, woof, woof. Secrets, you cannot store secrets in variables. You cannot store secrets in environment variables. You cannot store secrets in configuration file. You store secrets in secrets manager. There are secret managers in AWS, in Azure, in GCP, and if you are on-premise, you have HashiCorp and probably more. But you don't store secrets in configuration files. Come on, guys. Different door, same failure. This platform manages construction site records. This time, it's not variables. It's the DAG source view. That hands over database credentials, an application login, and a private access key, all ended in the DAG code. The previous case, and also this one, and also the next one, I reported this incident to the CERT in my country, which reports these incidents to the CERT of the other countries. This is true for those cases and also the one that will come next. Now, I want to tell you about a company you've never heard of. This is a B2B dynamic ticketing pricing platform. When you buy a seat to a big game or a touring show, software like this sets the price in real time. You know, when you try to buy a flight ticket and sometimes the price is changing, this is the thing. So it's wired into 30+ major clients: Major League Baseball, Minor League Baseball, soccer, football, and live entertainment. Its pipeline push prices into ticketing system, rebalance inventory, handle returns, and process real ticket barcodes, the sellable asset itself. Nobody has heard of this company. It's true, it's behind the scene, but they sit in the middle of the money and the tickets of dozens of major venues. All that thought, because this exact box is about to turn up wide open. So I found it via OSINT, April of this year. It's not 2021, it's not 1980s when everybody were such a good people, no hackers at all. It's 2021. You see in the screen the DAG list, and there was a pricing report and a barcode scanning DAG for every client, all the 30. And in this same box, variables. Live third-party API credentials, live ticketing system credentials for major league clients, named employees' emails, also known as a free spare phishing list, and a full AWS network topology. Awesome. So here's where this stopped being an infrastructure bug. The barcode scanning DAGs run for every one of those 30+ clients, and the task logs hold real, live ticket barcodes. Pull one from a log, clone it, resell it in a secondary market. Picture it. It's amazing. A fan buys a real seat. Someone clones the barcode straight out of the exposed log. At the gate, the clone scans first, and the person who actually paid it is the one turned away. It's not an infrastructure bug anymore. This is people. So as I said, it was only passive observation. I touched nothing, changed nothing, download nothing, sells nothing. The instance has been confirmed, take offline, and all the other instances as well, cert to cert. And I can say it's really wonderful that, there's something good to say about the governmental sector, because we like to say bad things, but they actually did it. They were confused, like, why are you talking to us? And I said, because I'm a citizen and I need your help. So they told me, okay, we'll think about it. And they actually did it. So it was wonderful. So we actually worked together between countries. And now I want to say the last something in the wild, and this slide was changed after I learned one or two things in Sky Talks. And the title of this slide is Admin, Airflow. Airflow ships both as quick start defaults, neither forced to rotate. Rumor, as it's someone, I don't know who, someone sprayed both against over 2,000 reachable showed and discovered instances. 247 boxes, 11% still accept one of the two. 261 successful logins total, no CV, no exploit, just the quick start password nobody rotates. And by the way, since these logins go out over plain HTTP, even a properly rotated password would still be sniffable. So, yeah. So, we saw Apache Airflow. We saw the wild DAGs. Let's dig into the code itself. Hopefully. Something is wrong. Can you help me? No. Something is wrong. Okay. We'll start with the concrete one because Airflow shipped it themselves. One of the Airflow own examples, DAGs, echoes the run ID straight into the bash command. And run ID is literally the box you type in the trigger run form. So anyone who can trigger a DAG gets OS command injection. That CVE was fixed years ago, and it lived in free, enabled by default, until then. And it's not just an admin typing it. The input also arrives through a trigger REST API, through anyone holding Airflow user or operation role. It's not admins. So let's see the example in the next slide. Yeah, so here you can see the template. You run the run ID, and the run ID can be a Linux command in this case, and we'll see how it works. Okay, so here is the admin, and the admin can see the DAG source, and it gets as an input the run ID, and soon we'll have the analyst, and the analyst triggers the DAG with command of her choice. And soon you will see the results in the log of Apache Airflow. Yeah. Sooner or later. Yeah. Okay, so this is the render template, and soon we'll see the results of the ID Linux command in the log. Nice, isn't it? Woof, woof, woo! But now I don't have this, where is it? It's difficult to move it, yeah, okay. Now there is the Redis worker, which push the tasks into the Celery executor of Apache Airflow. The worker to API server boundary is not the only service that only exists once you go distributed. Celery executor, insert Redis or RabbitMQ between the scheduler and the workers, and like that the boundary, and simply does not exist in a single node. The Redis default is for no authentication, so the broker that's reachable in wide open, and you see the picture. There also in the background we have Redis, we have Flower that monitors the UI, and all of them, the defaults of all of them is no authentication. Let's see, and now I want to show you, because it's really cute, I want to show you, let's see. Okay, here we go. Okay, so because it's cute, like you can talk to Redis using the CLI. So this is Redis, and there are a few commands that you can use. You can use ping, you can use lrange to see the messages that are in the list. You can push messages to Redis, and then you can see in the output that we have the list, including the message that we push. So for Apache Airflow, actually they fixed the vulnerability in version 2. Can you help me? Oh, okay. So in version 2.10, I think, they fixed the vulnerability. Like you can, if the Redis is without authentication, you can see the list using the Redis CLI. But if you push something from the outside, from the Redis directly, Apache Airflow will not run it. Before version 2.10, you actually could push the command into the Redis directly into Apache Airflow. What else? You can also you can also forge a task execution API token. So Airflow puts workers behind API server with short-lived JOT, specifically to kill the 2x blast radius, where every worker held the Fernet key and the DB credentials directly. But the token itself is just HS 512 signed over one share secret. Woof, woo! If that secret woof woof is wicked or guessable, I can forge a validly signed token for a completely phantom subject, a task instance ID that was never real. And here's what makes it work. The API never checks whether the subject belongs to a real current running task. It only verifies the signatures. So another attack vector. This one is mine. As soon as the talk was accepted to OASP Israel, the conference that canceled, I had a full 3 days to start the research. The conference was canceled, was delayed, and then I came back to my staff to get paid, okay? But I had 3 days, and on those 3 days back then, I found some instances in the wild and also this vulnerability. So it was found on 3.2.1, and of course, it fixed in the very next patch. They know, once again, I want to say that I really appreciate Apache Airflow team, security team especially, and also all the others. So the connection API redacts secrets by matching the field's name against a hard-coded allow list, not by looking at what the value is actually is. So password and token come back as stars, okay? Because those names are on the list. But what about webhook URL? They are not on the list. So a field is only protected if whoever named it happened to pick up an allow listed name. And webhook URL is the exact field name Airflow's own Slack integration documentation uses. Okay? So reduction here is not a security boundary, it's a name check, not a value check. So we read the connection over the API. As an analyst that wants to leave the organization, this bad analyst from the inside used the webhook URL, post a message in the channel, in the Slack channel of the company. Thank you. And we'll see how it goes. Okay. So here is the channel. And soon we'll see the attack script. Maybe you cannot see that much. Yeah, thank you. And full screen maybe. Yeah. Never mind. Yeah, maybe it will be better like this. Yeah, okay. So soon you will see the attack. The analyst will log in, get the JOT. After it gets the JOT, not the JOT, the webhook URL, JOT. Webhook URL, and then the analyst takes the webhook URL, public a message in the Slack. I don't think it's something. It doesn't work. It works. Okay. I forgot it, so it takes time. Okay. So this vulnerability got, yeah, it starts. So here we see the user, and it got the JOT after a login. And this is only a viewer. So when the viewer tried to see something confidential, it cannot do it. And then the analyst take the JOT, and the analyst will get the password, the token in stars, but the webhook URL is in plain text, and you can see it here. So then the analyst use this webhook URL and put a message in Slack. So this is medium 6.5, and as we spoke yesterday, my friend, this is medium. So if it's about me, it's maybe low. Why? Because I hate Slack. And I really try not to open Slack because I hate this application. But since my colleagues, especially marketing, and marketing, also product, they like Slack. And they send a lot of messages in Slack. If they will see such a message that you need to verify something, they probably click it. So for me, it's low. For them, it's more than medium, because they will probably click the link. We need to hurry up. I know. OK, I have the mouse. So, given all of that, what do you actually do? Someone told me that we shouldn't talk only about the problems, we should offer solutions. But you know the solutions. So if you run Apache Airflow, do this week. Find and isolate, inventory your own edges. Kill unauthenticated old version on site, and take the broker and the monitoring UI off the public internet. Fix the defaults. Secrets. Woo! Woof! Secrets go into a real backend. Never variables, never DAG source. Treat DAGs as a code execution surface and restrict who can read DAG source, because source leaks secrets too. And rotate anything that ever set in a variable, connection field, or DAG file. 4 verbs: find, isolate, fix the default, rotate. Now I am very excited. Because this is us. What I really like to do the most is to break stuff. This is where my curiosity goes. But with great power comes great responsibility. Everything I've shown you today maps to a real exploitable weaknesses. Use it to find and fix your own exposed instances and to disclose responsibly cert to cert. If you see something from another country, you can help them too. And never use it to break into someone else. Never, never. So this is me. Keep in touch, all of you. And let the DAGs out. Woo! Thank you so much.
Any questions for Ms. Sahar? There it is. Any questions for Ms. Sahar?
I have a question for you. Thank you for the great talk, Or, and for your responsible, ethical, friendly hacking. Tell me, please, in one line or two, the whole timeline from the inspiration to research the Airflow until you discovered the CVEs, reported them. So
Of course.
It was like months, weeks,
No,
days?
of course. So I'm really busy. I'm really busy. I'm during my secondary degree studies. Also, I work, and the first time I installed Apache Airflow was a year ago, I think, maybe a little bit more. And then I suspected something is wrong, especially after I installed the Apache Airflow 2.x. And I was looking for opportunity to research because I'm very busy. And I think it was on the OWASP talk supposed to be on March. So I started the research. And these 3 days, I disclosed some of the, not all the instances are here.
So you did this in 3 days.
That's
really impressive.
Yeah.
Congratulations to you.
Thank you so much. And I'm really excited because before the flight to the States, I found, I found the other CVE. And yeah, in the next conference, we'll cover this one as well.
Way to go.
Thank you so much.
Congratulations, all.
Thank you.
Ms. Sahar, thank you very much for your time.
Thanks,
Thanks, everyone.
Thank you so much. Now it's. Ta-da! תודה, איזה כיף לי שבאתם. תודה מותק.
Greetings, everyone. Thanks again for attending BSides 2026 here in Las Vegas. Ariel Ropek is Principal Threat Researcher at Databricks. He has over a decade of experience building detection, engineering, and threat intelligence teams. His experience spans internal security, managed security, and security product organizations, which has exposed him to a broad variety of networks to protect, adversaries to defend against. And that being said, please meet Mr. Ariel Ropek.
Hi, thanks everybody. Happy to be here. So I want to walk you all through a scenario. Pretend you are a SOC analyst at a large device insurance company, and you're on the night shift, everything's going well, and you receive this email to your security hotline. And it says, hey, we noticed that there seems to be a targeted supply chain attack against you and your affiliate organizations. We have a bunch of technical details that we're happy to share, and we just wanted to let you know that it looks like there's some pretty sophisticated malware out there targeting your CI/CD build pipelines and so on. And you say, wow, that sounds really serious. Let me go investigate that. I'm going to look up these packages on everybody's favorite open source package scanner, Socket, and it says, oh, wow, yeah, that's a real supply chain threat. You should probably do something about that. This appears to be known malware. It's definitely very low on the supply chain security spectrum, so definitely some serious things to be worried about, and again, appears to be targeted directly at your organization. So you say, wow, well, thanks for the heads up. We've contacted NPM and we've taken ownership of those namespaces, those scopes that the packages are using, and we've requested that NPM take down these packages. So we're going to do a full investigation, and appreciate the heads up. So now imagine that you are the CISO or a security manager for this organization, and you wake up in the morning and you do a quick news search like you usually do for your company, and you happen to see this, and you're like, oh my goodness, what is going on? Have we been hacked? Are we being targeted by a nation state? You do a little bit more research, you read some of the reports out there, you see that some research has been published showing that these packages have been out there. They have actual download counts, so it's being installed somewhere. The malware actually has some pretty sophisticated capabilities, stealing cloud credentials, access tokens, GitHub keys, and so on. And so you say, well, what's going on? So you kind of throw up the red flag, talk to everybody within your internal security organization, go through the entire timeline. You talk to that SOC analyst who got the original notification and who took down the NPM packages and so on. And then you find out after a couple of weeks of investigation that this was actually a controlled red team exercise done by your own internal red team. And you have to go now do damage control, follow up with all the news organizations that published articles about this and ask them to take your name out of the news. And I don't know if any of you have actually interacted with journalists, but that's not how the news works. They'll put in a disclaimer saying that this has been confirmed as internal red teaming, but is it red teaming or is it rect teaming? So this is what attackers see when they look at your bug bounty POC. So before we get going, just a little bit about me. My name is Ariel. I lead the threat research team at Panther, which is now Databricks. I think I'm supposed to say that this is my own research and ideas that's not endorsed by my company, but I'm not sure because I didn't ask them. I build threat intelligence teams and the tools that they use to track adversaries. And most recently, I and my team built a real-time supply chain scanner for the NPM registry. And we've found some really interesting things. We've scanned over 8 million packages since November of last year. And this is actually a talk in a series of talks that we're doing this fall around kind of what we've seen and how we go about doing this scanning. So I won't get into the details of how the scanner operates, but it does use some agentic AI capabilities alongside some traditional static analysis tools to scan these packages, and then we have it scaled out so it's scanning almost every NPM package within 5 minutes of it being published. So with that being said, there is sort of a symbiotic relationship or a trade-off between OPSEC, or operational security, and OSINT, open source intelligence. So when you publish things in a public place, like the NPM registry, you need to be really careful about what type of information you're exposing, because any failure in OPSEC on your part is an OSINT opportunity for someone like me to go in and see what you're doing. So this is something to really keep in mind. We're going to go into a lot more detail around this, but this is the two sides of the coin here. Is if you are not careful and if you expose information that's part of your red teaming exercise, other people can see it and will use it potentially against you. So, with that being said, I am not disclosing any vulnerabilities today. All of the things we're going to be talking about were published to the public NPM registry by the red teams and companies that we'll be talking about. There's no, like in a lot of cases, actually, we did report these to the companies in question, so they could be aware of them at least. But the disclosure was actually made by the red teams themselves. So I'm just going to be sharing IOCs because this is actual malware that we're going to be looking at that was published on NPM in public. Everyone in this room is welcome to go find all of these packages. I'll show you how to do that as well. This is now considered IOCs that I'm sharing to help people protect themselves. So what are the risks of doing this? We're going to look at 4 different examples that we caught firsthand with our scanner, and we're going to kind of score them based on how reckless these red teams were being. The first way we're going to score these is by capability. Are these kind of simple beacons just to test whether something gets installed or not, or is there actual malicious capability being published? So that's going to kind of determine whether or not your red teaming exercise gets written up in a security research paper. If it has real novel capabilities that nobody's seen before, that's indistinguishable from real malware. It is real malware. The other axis we're going to score these on is obviousness. Some of the examples will be very obvious that it's a red teaming exercise. Other examples we only know we're red teaming because the company retroactively came out and said, oh yeah, everybody calm down, don't panic, take our name out of the news, everything's fine. But on the other hand, like attackers also pose as red teams. Like just because you wrote in your package description that this is a approved security exercise, there's no reason a real attacker couldn't do that as well. We'll talk about reputational damage, which I'm sort of loosely defining as capability minus obviousness. So if you publish real malware and it's not obvious that it's authorized, there's no way for anybody to know that it's not real malware. We'll talk about the different OPSEC failure modes, exposing internal environment variables, private namespaces and scopes for NPM packages, internal domains and IP addresses, as well as dev tools and software dependencies that your company actually uses. We'll talk about parasitic attacks. All of the examples we're going to look at use the dependency confusion attack, and it's very easy to increment the dependency version by 1 and just run the attack again. And finally, we'll talk about domain takeover risks. So these are the trust anchors that you're putting into your NPM packages, and in some cases, those trust anchors become perpetual obligations that you, as the target organization, have to maintain forever. So without further ado, let's look at some examples. So this is the example we started with. This is an Asurian red team exercise as confirmed by them. You can see over here, this is a sample of the actual malicious payload. It is heavily, heavily obfuscated, very, hard to decipher what it actually does. But funny story, if you put this into an LLM, it will very easily generate equivalent plain text code. So we started seeing this when we first set up this scanner, where the LLM analysis would come back and it'd be like, oh, this is exactly what this code does. And we were like, no, that can't be right. You must be hallucinating. And so we went through the much more difficult process of sort of prompting it and coaxing it to show its work and actually step through the deobfuscation steps so you get the real deobfuscated code. But it turned out like 95% of the time, the one-shot version was correct. And what it's doing is not a true deobfuscation, it's reading the obfuscated code and generating plain text code with equivalent functionality. And so that was pretty amazing. If you want to learn more about that, I did a talk at BSides Boulder back in June, and that recording is on YouTube, I think. But anyway, so after we deobfuscated all of that, we found that it actually had some really sophisticated capabilities. First of all, it didn't show up on VirusTotal anywhere. So this was a totally custom piece of malware that was written specifically for this purpose. It had some pretty sophisticated anti-sandboxing and anti-analysis checks. So as it was executing, it was looking for certain known malware sandbox environment variables and things like that, and it would stop. We did most of this analysis through static analysis and LLMs, so we didn't run into that. But it also did a lot of information gathering, enumerating host names, usernames, network addresses. It harvested a whole bunch of secrets files, .env, bash, NPM registry credentials, as well as AWS and other cloud configurations and Docker keys. So like actually pulling these credentials and then exfiltrating them to an AWS. You can see down at the bottom here, it was exfiltrating to a AWS endpoint. So real capabilities, pretty sophisticated, and again, a novel payload that wasn't previously seen in VirusTotal. So let's score these along the rubric that we kind of discussed. So in terms of capability, this is pretty high. This has got the highest score capability-wise of the examples we're going to look at. The obfuscation and the actual harvesting of secrets and the exfiltration of those secrets to a external domain makes this real malware. If you installed this on your machine, it would grab all of those credential files from your computer and exfiltrate it. So this is not a controlled exercise. This is a real piece of malicious software that if you downloaded and executed would ruin your day. In terms of obviousness, there was nothing in the package description to suggest that this was an exercise. It was all kind of posing as legitimate software. The only thing that gave away potentially that it was a controlled exercise was the targeting, because the packages were actually named after the organizations that were being targeted. But again, a regular attacker would definitely be able to do that as well. In terms of takeover risk, it actually is relatively safe, because the NPM user was a Gmail account, so relatively difficult to take over somebody's Gmail account. And the C2 server was an Amazon AWS endpoint. So again, pretty difficult to take over an AWS endpoint in that way. In terms of OPSEC failure, again, the only kind of giveaway was the package names themselves, but as you saw with the news coverage, like it was actually a pretty significant OPSEC failure. And so I rated this one 6 out of 6 in terms of capability minus obviousness. It's indistinguishable from a real malware campaign. And then, yeah, one last thing is like some of these packages had download counts on NPM. So put yourself in an attacker's shoes. You see a dependency confusion attack. You see that it has active downloads. What is stopping you from copying that, increasing the version number by 1, and then just actually pwning that company? So again, the exploit is sort of handed up on a silver platter along with the targeting reconnaissance. So it's like, I can see this package has downloads. I know that somebody is installing it. I know that it works. Very simple to just increase that version number. So let's look at another example. This one's going to be a little bit different. This one is very obviously declared as a research exercise. The NPM user account was registered with a @disney.com email address. I did redact the person's name, but I'll leave as an exercise to the reader. It's very easy to go find and look them up on LinkedIn. And yeah, if you look at the package itself, it's relatively benign. It is grabbing environment variables and it's exposing these variable names, but it's just doing sort of a beacon to some DNS domain. The one thing I do want to call out is that beacon domain actually ends in a custom domain name. And that's something that can be a little bit risky that we'll get into in a little bit here, because domain names do expire. And if somebody sort of swooped that out from under you after it expired and you didn't have a chance to re-register it, whoever controls that domain now controls whatever that is serving. So in this case, it's not actually pulling anything from that. It's more of a beacon to just make sure the package is being installed. So relatively benign, but again, just something to be aware of. So let's look at what the scorecard looks like for this one. So capability is relatively low. It's harvesting some environment variables and posting them to an external endpoint. The obviousness is pretty high. Using a corporate email address to register your NPM user account, writing into the package description that this is an authorized test. It's fairly obvious. Again, this is a technique that attackers can and do copy. So it's still, we're not certain. We can't ever really be certain. But the use of the corporate domain to register the NPM account is a pretty good giveaway. The takeover risk is pretty low. I mean, I'm not going to be able to take over this person's email account. I could potentially take over that C2 domain if it ever expired. And then there's a bit of an OPSEC failure because we know exactly who this company is. We know exactly what environment variables were being harvested and so on. So this was a relatively benign example, kind of doing it right if you're going to do it this way. But again, if you run this through a malware scanner like Socket or anything like that, it will show up as a supply chain attack. It's objectively still harvesting information and posting it to external locations. So this one is very interesting. And for context, all of these were found in the kind of April to May timeframe. So all pretty close together. This one was interesting. This was a cluster of packages that were published by a single operator, and you can see all of the different package names and namespaces here. They were targeting Russian banking websites and Apple Pay type things. And the interesting thing is, if you look over at the code, it's using this moika.tech domain, which is some kind of Russian car wash technology company. So I did report this to their security email. I got a bounce back, so I don't know if they're monitoring that or anything. So my hypothesis is that these are technology partners that company uses. And so they're kind of testing their own company to see if their versions are pinned correctly on all of these external packages that they use. But in doing so, they're actually exposing all of these external companies to the same risks that we're talking about. They're sort of red teaming their own organization, but they're exposing all of these partner organizations to risk. Yeah, you can see there's a couple of alias accounts using yandex.ru email addresses. And the really interesting thing about this one is it's not just beaconing to this custom domain, it is pulling a POC.js and doing an eval. So that's remote code execution. And the really dangerous part about this is whoever controls that domain can serve something different on that POC.js endpoint and turn what is hopefully now a benign payload into a malicious payload without ever changing this NPM package at all. So let's score this one. So in terms of capability, that alone gives it the highest level of capability, because it doesn't matter what that URL is serving today. If anybody else ever gains control over that domain, they can change what it's serving and switch it from a benign payload to a malicious payload. It's, I don't know, I'm on this might be lower obviousness than 2. I think it's, I don't know for sure that this is a red team exercise. That's my hypothesis, but it could also be a, you know, somebody compromised this domain and is using it to do further attacks against it. So it's unclear whether or not this is a red team exercise. There is definitely a takeover risk with that custom moika.tech domain. And there's a big OPSEC failure in that they're exposing all of their technology partners and the software that they use. Yep, so that's kind of that one. And then finally, as I was preparing the slides for this, another one came in. This one's very recent in the last month or so. This is a series of packages that appear to be targeting Epic Games and packages that they may use. This one's interesting because the payload is a single line pre-install script. So it's all self-contained. There is no obfuscation, but you can see there are exposed yeah, like Jenkins, TeamCity. So you can see the software that this organization is using. You can see internal like GitHub secret names and things like that. And then it's posting those to some raw IP address. So it's not using a custom domain. It's a hard-coded IP address. And then yeah, so it's definitely harvesting secrets and credentials and then posting them out. So we'd classify this one as an info stealer. So yeah, in terms of capability, it's not doing remote code execution, so a little bit lower. Definitely stealing secrets. It's a little bit obvious, but again, it's only because of the targeting that this cluster is run by the same operator, targeting 4 or 5 different packages that are all fairly similar in terms of like who would be running those packages, and then the OPSEC failure in terms of the exposed environment variable names and things like that. The one thing that this did a little bit better on is there's less takeover risk because the maintainer used a Gmail address, and the C2 was a raw IP address and a OAS.fun, which is a pretty widely used Interact SH service that you can use. So those are pretty hard to take over. So that got me thinking. We saw 4 of these examples in a relatively short time. This was all firsthand from our scanner, but it got me thinking, like, is this a new thing? Like, is this something that we're just discovering now? And so I started doing some more research, and it turns out that no, there are a lot of examples of this over the past 5 or 6 years. So the term dependency confusion was coined by Alex Bursan in this blog post where he got a big bug bounty from PayPal for doing this. And so that's the technique of publishing an NPM package with a very high version number. And if you don't have your versions pinned, if you say, like, I want my version at least this high, when you go to do an update or an install, it'll go to the registry and see, oh, wow, there's a 999 version number. I'm going to pull that in. And so that's where, like, you really want to do version pinning or also set a maximum version level. But when he did this, there were numerous copycats that came in after him. And it's like, oh, well, if you publish 999, I'm going to publish 9999. And especially when you can see the active download counts, you have a pretty good idea of what is working and what is not. And so then this is another example. This is a screenshot from a Sonotype blog from 2023. You can see that Sonotype confirmed with the author that this was part of an ethical research experiment. So it's not only internal red teams that are doing this. There's people out there doing bug bounties, and yeah, this one's we'll get into more detail on this one specifically. This is a blog post from Socket in 2025, where they're basically calling out Sneak for doing this targeting cursor. And so now we have like two vendors sort of like naming and shaming, saying like, hey, why are you doing this? It looks like malware because it is malware. Here's another one. This is, again, this Lupin name comes up a lot. This appears to be some kind of pen testing or bug bounty company that does this quite a bit. They got a big bug bounty from Netflix for doing this in 2025. And then finally, this is a blog post from SafeDep, where they published a report about a supply chain attack targeting this Scudero repo, where they had to later go back and update the post saying like, oh yeah, we were told that this was, retroactively told that this was a red team exercise. So this is actually something that happens quite a bit. I'm not going to go through the other 10 examples that I found, but it is quite prevalent and something that you should definitely be aware of. And so the other thing I want to kind of drive home here is that the risks are real. So let's take a closer look at this Zettel thing from 2023. This is the package. Again, this is a blown up screenshot from the Sonotype blog, so it's a little bit hard to read. But you can see that this is 0xlupin.com custom domain for the C2. But more importantly, the NPM user who published this package was using this at pentest-lupin.com domain. And so I thought, hey, I wonder when this domain is expiring. And I looked it up, and it turns out, as I was looking it up, it expired on April 30th of this year. And so at that time, I could have registered that domain, changed the MX record to have email redirected to my own mail server, reset the NPM password for that account, and now I control all of those NPM packages that this pen tester has ever created. And so I didn't do that. I don't know, show of hands, would the talk be more interesting if I had actually done this? I decided not to because I'm trying to encourage people not to do this, because the point is that by using these custom domains, that becomes a perpetual trust anchor that both you as the researcher and the target organization now have to maintain forever. And I'll get into why the forever applies, but I didn't want to take that responsibility on for myself. I don't want to maintain this trust anchor. But it is, so this domain has since been re-registered. I don't know by who. It could be the original owner. It could be some other malicious actor. It's really hard to know. And so the other thing I want to kind of illustrate is that even if you get NPM to take down the packages are still there. I'm not connected to the Wi-Fi, so I'm not going to do a live demo. But you can look up this package on the main NPM registry. It's not there. But if you go to the Chinese mirror, it's there. You can download it. You can analyze the malware. Be careful with this one because it's real malware. There's also a handy tool that Paul McCarty of Open Source Malware made called Undelete that just scans all of the Chinese mirrors, and it's very easy to find any package you want. He's actually doing a talk at Adversary Village So definitely check him out. He's great. But yeah, so these packages, even if you think they've been taken down, they're really not. And then there's people like me who are just scanning all of NPM and storing every package ever published in an S3 bucket. So like I have them. And in addition to that, when your computer or Docker image or build pipeline installs a package. So like let's say your system was vulnerable to this dependency confusion attack. It got installed on your system. It's now in the NPM cache on that system. And so even if you go and do the version pinning, it downgrades to a safe version. The malicious version is still there unless you go and clear your NPM cache. And if at any point in the future you have a regression where your version pinning gets messed up or reverted, it will revert to the cached high version number package before it goes out to the registry. So are you sure that there aren't any of these packages in your cache? So even beyond taking down from the registry, you have to be really careful about like clearing these all out after a red teaming exercise or otherwise. So what should we do about this? Well, the registries are kind of getting wise to it, and they're making some changes gradually. So back in July, so just about a month ago, or what day is it? Less than a month ago. Anyway, that one's from 2025. So yeah, in 2025, they made OIDC publishing generally available, which means when you publish NPM packages, you can have like two-factor essentially. And so you should do that. Even if you're a security researcher doing throwaway bug bounties, you should hook up OIDC to your NPM account so people can't take over your account. And when you publish something, you can verify it that it's you. So that's a feature that they've added, which is something everybody should do. Registries could make install scripts not run by default. And there are some breaking changes coming out soon. So that was announced a couple of months ago. Yeah, most of these attacks that we see are run during the install scripts. So you install or update an NPM package, it runs a bunch of install scripts. One of them is malicious. It goes and does a bunch of stuff. So again, that's coming, hopefully. That's definitely the main attack vector for this type of malware. And then the last one I wanted to talk about was namespace isolation. If you're publishing packages into namespaces, that's the like @org/package name. If you don't own that namespace, why do you need network calls in your installs? Like why, when installing a package, why does it need a network connection at all? That's kind of weird. And then again, they also announced just a couple of weeks ago that they're going to do publish time malware scanning. So we'll see how well that works. What to do if you're a red teamer? Well, first of all, don't do this. Don't publish working exploits on NPM. You can set up an internal registry for your organization, which is actually also one of the best defensive measures against all of these attacks. And you can run the same kind of red teaming exercise using your internal mirror. It's a little bit more work to set up, but it is definitely worth it. If you publish malware in a public place, no one can tell that it's not malware. If you do, which you shouldn't, don't give away your OPSEC, so protect your organization's internal secrets, but also be aware that the more you protect your OPSEC, the more you look like a real attacker, and nobody can tell the difference. And then from a defender side, these are sort of recommendations around how to secure your pipeline so you're not susceptible to this type of dependency confusion attack. starting with the easiest and working down to the more sophisticated and difficult, but just scope pinning in your NPM files, like name your internal package scopes and pin them so nobody can come in with a different named scope with the same package name. And then you can do defensive scope registration on NPM. So if you have an internal package scope, you can contact NPM and say, hey, we own this scope. Please don't allow anybody to publish under this scope unless they're us. Very easy to do. And then set rules of engagement for your red team and pen testers. A little bit harder will be, setting up a private internal mirror with an allow list for packages, so everything goes through your internal system first before reaching out to the public registry, doing ignore scripts by default in all of your build pipelines, and doing exact version pinning in all of your lock files. And then if you want to get really crazy, you can do egress filtering. So like, again, why do your install scripts need network connections? Cooldown gates, that's something I think GitHub introduced as well, where for Dependabot, it now waits a few days after a release to say, hey, here's a Dependabot update, because in a lot of these supply chain attacks, if you just wait a day, somebody else will get pwned, and then you can be like, oh yeah, I'm not going to install that. So easy stuff. And then, yeah, just audit your red teams. Make sure they're not doing this. Define some rules of engagement. Explicitly articulate what you consider sensitive information about your company. So again, protect your OPSEC. Don't let people create these perpetual trust anchors. So no custom domains for NPM user account registration or for C2s, and limit the capabilities. Like, don't let your red team develop like a novel, like working exploit that nobody's ever seen before. Because again, like I could just grab that and use it. So yeah, that's my talk. Thank you, everybody. This is part of a series of talks around the research that we're doing in NPM using this scanning tool. I talked about how we're using the agentic driven malware analysis back in BSides Boulder in June. My colleague Alessandra and I have a workshop at Recon Village this Saturday, so definitely check that out. She's speaking at BSides Montreal in September, and then we'll be in Brussels talking about some of the capabilities that we've built for the scanner in October. So thank you.
Any questions for Mr. Ropek? No one? All right, thanks again, Mr. Ropek, for your time. Thank you, everyone.
Thank you.
Greetings, everyone. Welcome back to BSides 2026 here in Las Vegas. Ignacio Navarro, an ethical hacker and security researcher from Cordoba, Argentina, has around 6 years of cybersecurity experience, and he is currently working in application security. His interests include code analysis, web application security, and cloud security. He's a speaker at the upcoming DEF CON, as well as H2HC, Troopers, LAHAC, NorthSec, Typhoon Con, Security Fest, SASCON 8.8, blah, 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 blah. In other words, he's been around, and apparently he's also going to take us around. Please meet Ignacio Navarro.
Thank you, thank you. Good morning, everyone. I expect less people, to be honest. I mean, it's almost the last talk of the day. We are quite tired, everyone. We need to get ready for the pool party. I presented the part 2 yesterday before the part 1 at SkyTalk, so maybe of you were there. So now we want to see the whole story about how it begins, the initial access, the persistence, and some other findings. I'm Ignacio Navarro. I'm from Córdoba, Argentina. I work as application security for a small insurance company over there. And also in my free time, I do some ethical hacking stuff. And that's the Twitter, the LinkedIn, GitHub, if you have any question. I think we're going to have enough time after this one, but just in case. And also some fun fact, I love sneakers, and also I make my own clothes sometimes. Yesterday they did the same. So that's just some fun part. About the agenda, a little introduction, how I found the system, the landing page, like the main one, the DVR that they have in each buses or just in the private companies. Some stuff about the GitLab repository, the GitLab server, some cron FTP, additional server that they have, because it's not just only the buses, it's something about the rental bikes, the taxis, and that. Some conclusions, and that's all. But first of all, when I was walking around on Monday, I found this sign and I took a picture. I thought that the difference between hacker and cyber criminals was already solved, but it seems that no. And also I thought that the people who generate the chaos are the ones who are bombarding countries or taking down presidents in Latin America. But what I'm gonna say about you guys, I mean, in Argentina right now, they are debating in the Congress the law of ownership of foreign lands. So basically any random company around the world can go there and take all the resources from Argentina for a small price. So we are in the same shit too. A little disclaimer just in case, because we are the one who generate the chaos. This one is just for educational purposes, so don't do this stuff at your home. And if you found something, just report it. December 2025, I went to Uruguay to film a documentary from the people from Offensive X. It's a conference in Greece. And the last episode was about hacking in Latin America, so I just went there, filmed the last episode on that. And then I come back to Cordoba, where I live. Cordoba is just right in the middle of Argentina, and we are the capital of Fernet. It's an Italian liquor, but we mix with cola, and that tastes awesome. I strongly recommend the stuff. So it's like 3 hours from Cordoba capital and Rio Cuarto, where I live. So I was in the bus, just chilling around, looking all this stuff. And I found that they have like the ticketing system inside the buses when you can just put your car, and that's all. And also they have some cameras, so I Googled the name of the company who are in charge of those. I mean, in charge, the one who sells the whole stuff, the service, because those staff are mostly Chinese and that. So they say, okay, we're working more than 20 provinces, we have around 6,000 operations, consoles and that. And I started to, the name of the company was walking around my mind and say, okay, maybe it was familiar for me. So I went to check my mails, and I found that in 2018, I reported to them some SQLA injection. And but it was cool because they just fixed it super fast. And the first thing that I thought was that I'm getting old, maybe, because it was like 8 years ago. But the second one, I say, okay, if I report something some years ago and they were good, they were cool, maybe now it's going to be the same stuff. That is what I thought at the beginning. But then we're going to see. So they have the login page for all the administrator access. I tried to do the regular credential. I don't want to do some brute force or DOS over there because it wasn't the purpose of the talk. So I didn't find anything over there. I did a little go buster to check the different directories that they were exposing. And they were exposing the git ignore file. So I say, okay, maybe we can get something around. The Git in order were around 20, 26 stuff, some files, some folders that they were just from the company. It wasn't just a common name. But there was one who was quite interesting because that one also had the Git folder exposes too. So maybe basically we can just do some Git dumps over there and get all the files. And this service was for the cars inside the buses, but it wasn't that clear. The clear part was that they hard code all the credentials over there. So they have the config PHP with all the password, the usernames. But at least those were in the private network, so in the internal one. So we cannot use those credentials anywhere. So it was a little bit sad when I found it. So I started to check the different folders, the different file, the PHP one. And they were all the queries were using the PDO for the object, so there was no SQLi. But there was one who take the ID of the car, and there was some SQLa around. So first of all, we get the working directory. It was just some random stuff. And I tried to do some other stuff, because we can write on the TMP, but we cannot write in other different folders. And also, we cannot exfiltrate data, because that query were using another query after that one and another, so there was no chances to do some exfiltration. And after a few hours, I discovered that the database was in another server, so it wasn't making sense. So I came back to the Git folder, and I started to look around, and they had the Git config over there. And that was pointing to the GitLab server. And the GitLab server was exposed too. So we want to go in deep in that one, but later, because now we want to switch to other IP that I found. And it's the DVR system. In one of those ports I found in the 8080, they were exposed in some DVR. And it looks like, I don't know, a little bit shitty. And also all the part of multidimensional full access through AI and everything. If you see that stuff, at least it's weird. I mean, we see that the version was from 2021, and they have some CVS reported, but in our version there is no CVS, and I tried to Google a little bit more, but there was no information. I tried some default credentials too, and there was one who works. It was Prueba, who is Prueba, who is test in Spanish. But that account just had a few cameras, just 4 or 5, and we don't have any permission like administrator or something like that. But there was one part when you can take a screenshot of the camera, and it is saved in some storage, internal one. So I take a look, and the request who was sending was leading to just the full path of the stuff. So I say, okay, maybe we can try some LFI. And it works, so we can check all the different hosts and that. It was a Windows server. So I say, okay, maybe it's time to do some research about it. I don't know anything about it. I never do some pen tests on Windows, so I don't like Windows at all. So I did some research, and I found some different configuration manuals and that from the database backup, the Nginx stuff, the tone file. And some of that have the full path too, so maybe we can start to play a little bit with that. In this case, for example, we can see the backup folder for the databases. And also we have the GPS, a zip file from the last backup. It was from 2022. And there was almost 100 users, and the password were just the same password with the MD5. So we can do some crack over there, and that's all. But most of the account changed the pass because this was quite old, and there is no permission. But what about the FRM files? I mean, we can just take the FRM and the IDB, and we can do the recovery of the database, and that's all with the new stuff, because that's the live data. So we have the path, we have the user table's name from the last backup, so we can start to doing some database recovery. That's what we got those files, the 2 FRM and the IDB, and I use DBSEG for change the FRM to some schema SQL. Now it's the live demo, and I hope that this works. I mean, it's just simple. It's just the database recover, and that's all. Let's see. You see this. So the script. Maybe I can show Okay, so the script is everyone can read the stuff at the end and that? Okay. It's super simple. We just get dbsake. We add some. We changed the rope compact because it was on Chinese, so we need to do. We don't have any. I don't want any problem with the typos. We create just a random Docker with MySQL 5. We wait till it is initialized, and then we create the database. We do some alter table. We put the schema SQLA over there, and after that one, we put the IDB, who is the one who have all the data, because the FRM is just the schema of the table. We do another alter table, and that's all. We can see, in this case, we're going to get the first one, the number of the accounts, and the password and account from the first file. And it should work. Yesterday it worked. So. We're going to see a few warnings because I have a MacBook, and it works, but it's a little bit shit too. And then we have all the password in MD5, as I told you. So basically, we can just do some, maybe like this. Yeah. We can just try some random password like 6 zeros, and we can put it in MD5. So we go here. I put this one in here. Maybe it's not. At least it works. So. Okay. So we can see that there's at least 7 users with the 000 password. So we can just take one of those and try to log it in and see what's going on. I mean, having the password in MD5 in 2026. So we take one of those passwords and we log it in. Now we have access to more than 10 provinces. And I don't know where he put the flipper. Agatha. So we have 1,000 devices around with cameras, microphones. We had access to read and write the different user. We can create a new user, administrators one. We can hear, because the buses have like a microphone too, so you can hear all the stuff inside the buses. And also, it wasn't just buses, because maybe I have a private company, I want to hire the service for GPS and cameras for, I don't know, my trucks or something like that, so you can have it. And I presented this talk in June of in Poland, and there was around 1,000 devices on Sudan. So I checked it before I came here, and there are just 1,000 right now, and there is 81 in US. But don't do this stuff at your home. So we have full access now of the DVR system in all Argentina, because it's supposed to be just in my province, but then I started to figure out that they were using the same stuff in all Argentina too. But we can come back to the GitLab stuff. They have 4 projects. Most of those were just vibe coded YAML too, and they were doing some echo to the passwords, some echo to the GitLab stuff, to the Docker registry too. So we had access to the exposed Docker registry. We have more credentials, hard code. But there was one repo who was the most interesting one. It was called Chrome Web, and it was on localhost, but localhost means that that was in the public IP too. So I went to check in the main one, and it was exposed, obviously. And I say, okay, but this one is just to check. The real data is in cron control. So I went to cron control, and they were exposed in the Git folder too. I did another Git dump over there. And that one was the repo who controls all the different cron jobs, and that they have more files, more credentials, hard codes. For example, they have the bank and the government credentials. So basically, you can log it into some random nation FTP that they were sharing with other different companies inside Argentina, because they use it for telemetry and that. Also, they have the bank accounts. Basically, you can just log it in and do some transactions, bank transfers, and that. Some of those need some PM certificates, but the PM were around the server too. And there was one PHP file who was interesting one, who do some sync. So basically check all the files on the server, and then if those files are not inside the machine, they just download it, and that's all. And we had read and write access to the FTP server. So let's try to put some just simple PHP who do some system CMD, and that's all. I tried to run the sync command, and it didn't work. because it had a cron file that run once a day. So there was no chances. I mean, they already locked it, so it's just, there was no way to execute it, so the file was in the server, but no one is going to pull it. But if it runs once a day, maybe we can just take a break, and that's all. At that time, I was in Iguazu Falls at the north of Argentina. It's really beautiful. So I went to grab a beer, and after some hours, I came back to the room, and we go there, see? So before the stuff, it say, okay, there's no file inside the server. But after midnight, it say, okay, 200, okay. We try some random command, and we are the www data. So basically, we can execute some command inside the stuff. The first stuff that I checked, there was no network segmentation inside, so you can get access to all the different IP, private IP. We can use the credential from the database that I showed you at the beginning, for example. So it was our co-credential with read and write access to all the tables and that. There was around 6,000 administrator users, and the password were in MD5 too. They have more than 5 million cards because it was the same database for the whole Argentina too. About the payments, they also logs the payments. Like, I mean, when they generated tokens, they log the credentials too. So basically, we have a valid credential. We can manage the balance too. This one was for the one when the people want to charge some money inside the cars. So we can see who charged the money, in which car, where they live, which car they use, the numbers and that. And the credentials were working. I mean, I did this stuff when I was writing the talk, and they never rotate the passwords or something like that. And we have all the permissions inside the account. There was one folder too that they were exposing the picture of the ID of the people, the payslip, the certificate of residence, of schooling too. Because if you're a student, you can get some discount too, or if you work, you can get some stuff. And I thought it was just a joke, and that's all. But I do LS over there, and there was more than 20,000 ID pictures in that server exposed to the network. So it was getting bigger and bigger and bigger. Fortunately, I just do this stuff just for a week, because if not, I don't want to get caught in the middle. Because you want to say, yeah, it was an ethical hacking stuff. But you're inside someone's server with a lot of data, so you need to take care. About the administrator access, I went to the page that I showed you at the beginning. We can see all different maps. We have access to the monitoring center, to the report, the configuration. We can change the fares for all the buses. We can just put it on 0, and everyone can travel for free. We can be Robin Hood if we want. We can edit the cards. We can set some discount. Maybe don't change the fare, but if you set the 100% discount for everyone, it's going to be the same. You can create some golden cards like a master ones. About the drivers, you can see who is driving in each bus, where they live, what is their number, the licenses. You can see the message. For example, this one, hey man, you don't need to use the phone when you are driving, take care. But there was one other thing that was more interesting for me, and it was the remote management, the sending commands. You can send some commands like that message that I show you. You can turn on the lights, you can set a panic button, you can call the police and something like that. But also you can cut off the fuel and turn off the buses. So basically it was more complicated, because you can do the stuff for one bus or for all the buses. So that's the chaos that they were saying at the beginning and the big sign on the street. So you can do some weird shit over there. At the time, I say, okay, no more web application. I just want to switch. And I see that they were exposing the APK, the application that they use in those machines. It was hosted in the server, so I get it, I decode it, I decompile it, and it was in plain text, so you have all the Cs, the passwords. Also, they have like a connection between the nation system called SUBE, so you can see some stuff over there. And yesterday, Sky told you, so other stuff. About the taxi, you have full access for the taxi platform, like the Uber one, for example. This one is from Córdoba. So you can see all the balance, how the people pay, which one is the wallet of each driver, the license of the buses, track the different cars, the history of each person. You can see all the information around the message. They also have a rental bike stuff where you can see all the bikes are over there, all the users. In this case, were more 100 and 115K. But also, there was one part that I like, and it's the sanctions. You can see a sanction for the people. For example, this one. I say, he stole 2 helmets at the station. And it was selling on Facebook Marketplace. He doesn't wear any safety gear, running a red light, and crashing into a motorcycle. Very serious, 14 days. I think it should be more days, but it's okay. And this one is my favorite. Crashed into a taxi, replaced the wheel, and brought the bike disassembled. So, about the government. This one was the most complicated part because, as I told you, I don't want to have any problem with the Argentine government right now because the guy with the crazy hair and the chainsaw, I'm not in that part. So we have access to the government platform where we can see all the license, the people who are driving, who is inside those buses. We can see information about the vehicles, for example, if the vehicle is approved or not, if it has insurance, the difference ID, where the driver lives. And so at that time I say, okay, maybe it's time to stop the research and report the stuff immediately. Because from the initial access to this one, it was just week and a half, 2 weeks. So I started the disclosure process. I sent 3 emails to the company. I mean, if I sent some email 8 years ago and they were cool, maybe now they're gonna be cool too. But there was no news from that side. So I say, okay, it's fine. And I was talking with one journalist from Argentina. We released the article this morning. So he told me, okay, maybe you can try to report to the CERT, the Incident Response Center in Argentina. So I reported, and it was super cool because just in 2-3 days, they replied to me, they asked for more data. And in 3-4 days more, they say, okay, we already report that stuff to the company in our side, from the government, from the TP and that, we already rotate the credentials and that. So everything is gonna be okay. There's not gonna be any problem with the law when I come back to Argentina, I hope so. And about the conclusion, we got access to more than 1,000 devices. We can see all the cameras, we can see all the users, we can charge some money, we can do some bank transfer we have access to the government FTP, exposed credentials, the Ubers, the sanctions, the most fun part. So it was like a big stuff. And the conclusion is don't underestimate small bugs. I mean, as you can see, it was just a chain of different small bugs that you can full access to the whole system in a country. So read some code. I mean, it's just basic. I do application, I like to read code. I don't use any type of AI or something like that. I don't know, I think I do this stuff because I like it, not because I want to get paid for this one. And I enjoy the process. So it's okay. Don't expect any reward from something. I mean, if you're reporting something, they don't want to give you money. I mean, you are inside their system. Now hacking is illegal. It shouldn't be I think it should be illegal, but it is, unfortunately. So just take care. I mean, you cannot go around hacking some people's system. If you're in the company side or the government, just don't be an asshole and reply the email. I mean, we don't want your money. We just want to make the data safe. I mean, my data is inside the server, my mom data, my grandfather, and everything is inside that stuff. In Latin America, we can see each day, each week, there's a lot of people, a lot of new league company or organization that they were selling the data just online. So it's just that we are trying to make everything a little bit more safe. And the last one is go hack some shit. So have some fun, and thank you so much, everyone.
Any questions for Mr. Navarro? No questions? Oh, got one.
I just say, on the government thing, when you got the response back saying that it was fixed, did you ever go back and like verify that a fix was actually implemented?
I checked the first initial access, like the GitLab and that stuff, and they already fixed it. At least they are not exposing it. So I think from the government side, they rotate all the credentials, and from the company, they change the initial access stuff. But I'm 100% sure that inside the database and all the stuff, they didn't change any. I mean, they're going to be the same password, MD5, hard coding credentials, and that. So.
I just had a question. I think I understood that you contacted a journalist about this and that an article was published today. And where was it published?
Oh, it was published in Clarín. It's like media from Argentina.
Yeah.
So-
some of us do research too. I'm just very interested in
Yeah,
it.
it's on Clarin. I posted on LinkedIn too. So
Excellent. Thank you.
you can find. Thank you.
For the fuel cutoff trigger, were those buses diesel, natural gas, or was there any indication?
I don't know about maybe diesel. I think in Argentina it's mostly diesel. All the buses and trucks. So
Okay. Any idea how old the buses were?
no. No, because also it's most about the DVR stuff. So you can have new buses or old one, but the important part is DVR, that they were using some Android stuff for some SIM card stuff for the connections. Some of those have Starlink or something like that, but the old ones have just a SIM card and they just create some APN and that.
We have time for one more. Anyone? All right, looks like we have a security detail up in here, so we're going to let them through. Otherwise, again, thanks, Mr. Navarro. Thanks, everyone.
Yeah, thank you. That's perfect.
here in Las Vegas. Our final talk, at least in this room for today, is with Mr. Loeffler. He's going to be talking about the end of the beginning. I don't know what that means yet. I don't know where to begin myself. I'll just let him begin. Mr. Loeffler, the floor is yours.
It's too easy to give up. Despair creeps in everywhere. You're taking a beating every day. That's part of what modern life is. And the important part is to stay standing and to keep fighting. I've had a real good time doing the stuff that we've done over the last 10 years. And I want to thank B-Sides specifically because all of us, are kind of the last bastion of old school hacker talks. Something that's accessible and affordable, places where people can come and share ideas, not be afraid of things. And it's important to carry things forward and see how things develop toward the future. On a personal note, I would like to thank the collective that I've been part of. They've been very good to me. I'm lucky enough that I get to stand up here and brag about great projects that I didn't do much of, which is pretty wild because they're really great projects, and I get to kind of stand up here and go, how cool. So thanks to all of them, and thanks to everybody who's been part of Four Thieves over the last 10 years. There have been hundreds of people who've come and gone, and I'm grateful for every single one. Now, for anybody who knows me, I don't have stage fright. This is not what I'm scared about. What I'm scared about is I don't know what's gonna happen next. Usually, when I do these sorts of shticks, I have a pretty set pattern. Things are kind of set. I have all the magician's tricks that are like ready to go. And that is not the case today. So just give me some slack. This is gonna get weird. I hope you're all game for that. We cool? Here's an example of what my shtick typically is. I'll find some horrible person who took some very important life-saving medication. We'll sort of look at what they did, and we hijack what they're keeping barriered from people who need it. Then the next thing that I do is we take it and come on. Then I pass it to the crowd. This was 2016. I made these pills on stage. Here I am throwing them. And then the next thing I did was I called his phone. And that was fun. And then 2 years later, I sort of repeated the process. This is Heather Bresch. She was bearing the EpiPencil. And again, we made our own hijacked version. And then again, I passed it out. I hit somebody in the head. I still feel bad about that, but it was a really dark room. And then I called her. So I've got like a standard shtick. And I did this again 2 years ago. This was really fun. This is the hepatitis C cure. That's Daniel O'Day, and we managed to take this exorbitantly priced medication, make it for super cheap, and I did the same thing. We passed it out. Somebody got this bottle of pills. It was a full course of treatment. And then I called him on the phone. It was kind of a wild moment. He didn't want to chat. It got recorded. You can watch it. But it was a good time. But I don't really have my standard thing. And I was talking with a member of the collective last week, and I was kind of freaking out. I was like, what if I don't have anything new to present? What if, what if I don't have anybody to call? Like, what do I do? And this particular person was nice enough to say this. And I said, I freak out like this every time? Yeah. So I checked with somebody else. I said, look, one of the other people, they said I freak out every time. And there was this sort of cascade of conversations I had where I would sort of realize that clearly there was a joke that everybody knew but me. So, let me see if I can pull out one more surprise. So, we're so proud of all the work we've done. This was the EpiPencil. It was great. And the big deal was not that we made it and passed them out. The big deal is that it's very easy to do. And lots of people did it. This is a simple thing, off-the-shelf parts. It's very cheap. It takes no skill to put together. And there are people who are alive instead of dead because they copied this work, which was the idea. That's spectacular. And proud as we are of that, that's kind of not the big deal. But again, here was another one. We figured out a way to put abortion drugs on a business card. And now, again, it wasn't the big deal that we did that, although we made a bunch of them and we passed them out and we put them in some interesting places. The big deal is that this has been copied. People have done this over and over and over again, and there are tens of thousands of cards that we didn't make and were not involved in that are now all over the world. That's a big deal. And yet, that's not the biggest deal. Still, all of these projects, again, I'm so happy. This is so fun. Most of you have not seen this. This is a custom holster that was made for me when we were doing the DIY HRT project to hold this 70s subcutaneous injection gun. This was custom made. Shout out to the guy who made this. This was so fun. And we did a wonderful project on DIY HRT. Again, one of these things, one of the few places where you see DIY medicine actually happening. And pleased as we were that we figured out how to do that, and pleased as we were that we were able to hand out some things, the really big deal is that people are doing this themselves. Spoiler alert, one of the few places that medicine hijacking happened before us was with trans people. So credit where due, legit OG biohackers beat us to the punch, and we follow their footsteps. So, this was another one that those of you who saw us at Sky Talks last year saw. This is GSK 744. It's marketed as cabotegravir. This is a 4th generation antiretroviral. And we figured out a way to make it, and I had some, and I passed it out. And again, very fun, we're very pleased, but not the big deal. These were the pills. Aren't they cute? They're purple. This is the micro lab. Of our projects, this is the flagship. This is an automated programmable chemical reactor that will take a program, run it, and do all the hard parts of the synthesis. And yeah, we made some of these, and we passed them out, and we made some stuff with them. But the big deal is that already people have made their own versions, they've forked it, it's on GitHub, it's really well documented. Some guy in Germany used it as his capstone project, as his degree program. Last week, a guy on another continent, in another country, used it to make metformin, okay? And these are pictures that I was sent. This is a coffee filter, okay? He did this in his kitchen using the microlab. And he made metformin, and I know what this looks like. Typically, people are like, oh my God, would you? Well, he took it to a lab and had it analyzed. I don't know if you know how to read an NMR, but it's 99.4% pure from something he put together in his kitchen. For those of you who don't know, that's over 10 times the purity of what you would get from a pill that you got from a pharmacy. So there's a benchmark worth noting. And as pleased as we are about all of these projects, that's not the big deal. The big deal is that we showed that it's possible. It's not so much what we did, it's how we did it. The fact is, everybody said we couldn't do it. And over again, I'm sorry. This is a big deal for me. the wonderful people that I work with overcame everything, showed everybody that things that seemed impossible were possible. And I want to show you how. So, here's how you do this. Let's tear the curtain. I want you to see how the trick works. Now, a lot of people ask this. They're like, oh my God, you're doing such great work. Why would you do this? Well, it's really important to do this. If you end up being the institution you were trying to supplant, you fucked it up wholesale. And that happens way too often. So often people who are trying to build movements break the very movements that they built because they want them to last forever. I've been very lucky that I worked with some very visionary people who understood from the start 10 years ago that the goal had to be to disband. If you're doing any humanitarian work, by definition, your business is to put yourself out of business. Your job is to make yourself obsolete, because if you're still doing this stuff in a decade or two, the bus left. You missed it. It's over. You lost. If you stop fighting. So, this is the big deal. And I know everybody in this room understands this, because the magic of open source, the ability to copy a project that somebody has documented well, it's so fun because now so many people have done so many projects and they're so well documented. You think about something, you're like, oh God, I wish I could build blank. And then you look online, somebody's done it. And then you can just do what they did and recreate it. Here's the problem. We're the only ones doing that with pharmaceuticals, and that needs to change. So, welcome everyone. You're the collective now. So, let me show you a few tricks. First thing to do is you need to tap into the thing that you're passionate about, because this is difficult. It takes a lot of work, and it's largely thankless. But if you can figure out something that angers you enough, or builds your passion enough, or makes you happy enough, and then you figure out how that matches with what you know how to do, maybe collect a few friends along the way, you can get it done. But you have to not give up. So, here's what's going to happen. Now, I'm not saying I can predict the future, but probabilistically, this is what's going to happen. Maybe not today, maybe not tomorrow, but at some point, you're going to stumble across something. It's going to be a PopSci article. It's going to come up in your feed. There's going to be a thing, and you're going to see some article that says something or other about some magical thing that's not available. And you're going to go, And what you need to do is you need to go to the bottom of that article where it says where the original research came from. And that's going to point you somewhere, and then you need to go to the bottom of that, find out where the original research was published, and eventually you'll get to the scientific literature. Now, problem with scientific literature is oftentimes it's paywalled, but we have some friends who have done some things about that. And you look for the DOI, I imagine most of you know this trick, and you can go download it. Then you read what other people did. Mind you, they're humans. They're not much different than you are. And you just do what they did. Now, I know that sounds a little simplistic. It's not simplistic. It's difficult. There's a lot of work that goes into that. But that's kind of it. So, if you're looking at a medicine, medicines come into being through a very specific pipeline. Somebody has an idea for a mechanism of action, then somebody tries it in a petri dish, then they try it in animals, eventually it gets tried in humans, all right? When you find the thing that you want, it's gonna be in one of these stages, and proportionally more difficult if it's further to the left. So, trials look like this. They have 3 or 4 phases, depending on how you count. The first one is just to make sure it's not super toxic and doesn't kill people. The second one is to make sure it actually has some therapeutic effect. And then the third one is to make sure that it does better than the current leading brand. This is a very strange benchmark, and it's where a lot of drugs fail. If you have a drug that works really, really well, but not for the majority of the population, it sits on a shelf. If you've got a drug that works really, really well, but only in one sector of the gender spectrum, it sits on a shelf. And there are oodles of these things waiting to be hijacked. So, what do you do with this? Well, 3 standard ways that you can hijack a drug. And these are the 3 ways that we hijack drugs. The first one, of course, is not very novel. If it's available in another country, you just buy it. If it's already prepackaged, there are plenty of people who are churning out drugs and they don't much care who they sell to. Second thing, you can buy the active pharmaceutical ingredient. It's usually a white powder. I know what you're thinking. But you just put it into pills, or you formulate it into whatever delivery mechanism is necessary, and these are standard things. You're just replicating what would be done in a factory. The hardest, most difficult way, of course, is to do the chemistry and synthesize it. But again, this has a standard methodology. You go through, you find the chemical literature where that drug has been written about, you find the patents where they wrote about how they manufacture it. It's an instruction set. It has to be legally. Now, oftentimes it's poorly written, but that's all it is. Now, these last 2, we did. Chemhactica is a tool that will allow you to reverse engineer a synthesis pathway for a given drug. You drop it in, and it's a smart machine. Not an LLM, by the way. But it uses some machine learning to build it, that it goes through the past several hundred years of chemical literature, and it looks for synthesis pathways that it can combinatorially connect, and it gives you the easiest, cheapest way to create a given molecule. And you can give it guardrails if you don't want it to order anything that's controlled, or if you don't want it to order anything that's too expensive, or things that are toxic to humans. You can put that in. We host this now, and you can rip it, and you can mirror it, and you can run it wherever you want. And then you can plug it into the recipe press, which takes those procedures and turns them into programs that then run on the microlab. All of this is available for free. Just go on our website and clone it. That's what it's for. But this is the important part. If you don't clone it, it won't do anything. If it just stays like a cool idea that happened for a while, then this is over. And so you all need to decide if you want to see this keep happening, and you just have to decide to do it. Where do you get drugs? Anywhere. There are so many places. If you want to buy chemicals, there are so many people who are dying to sell to you. Most of these sites are aggregators. You put in a CAS number that talks about what chemical you'd like, and it just pops up a list of vendors who are dying to sell you stuff. Send them an email. Be polite. It helps. Make a deal, get some stuff in the mail, make your drugs. You should do it. I know you're all thinking of some drug where you're like, oh God, that means I don't have to talk, I don't need to go through some doctor who treats me like a used car. Yes, just go do it. Just go do it. Now, one thing to watch out for. Chemicals are graded in terms of their purity. There are a bunch of different weird names. There's not a strict hierarchy. The definitions are weird, and it makes almost no sense. Fixed it for you. The blue category. If you get drugs that have the purity that is in the blue category, you can just take it because it's safe. If you've got stuff in the green category, if you need it for 10 or so days, anything that's impure in there is not going to build up. These ones in the red category, probably don't put them in your body. If you come across something that has only made its way to the animal model, you're going to have to convert because humans are not like these other ones, but this is the standard model that they use to design the human trials. So if a human trial hasn't happened, just make your own human trial the way they would have. Yours is going to be better too, because it's going to be tailored specifically to you. Now, how do you check your dosage? Here's how. You've got this zone over here where things are going to hurt you. And then you've got this zone down here where things aren't going to happen. So between this point and this point is going to be your target dosage. So what do? Start at the left, work your way up. And there's a standard methodology for this as well. So you start converting, you start at that minimum, and then you use the Fibonacci sequence. I promise you I didn't make this up. You just ramp up. You start, then you double it, then if that doesn't work, you do that again times 1.5. If that doesn't work, 1.33, and then 1.3 over and over again until either you give up because you decide it's not going to work or it does something. And this way you can do an N=1 real-time adaptive trial on yourself, no institution needed. Now you get your drugs in the mail, and you're like, how do I know they actually sent me what I ordered? Well, a few years ago, when we were doing the DIY HRT thing, the brilliant people that I work with developed a set of systems by which you can test drugs without having to send them to a lab. You can do sharp melting points, you can do this analog, there's a digital way that you can control it, you can do reagent tests. These are off the shelf, designed for testing street drugs, or for like $30 you can build yourself a Raman spectrometer. All of these things are detailed, you can go use them, and you don't have to trust anybody. You know, trust but verify. All of these things are usable. Remember, you're just replicating. If you wanted to invent a new drug, I would be like, wow, okay, that's hard. But if you're just trying to replicate a drug that's already on the shelf, that's been done hundreds of thousands of times. You're just replicating it properly. The hard part's already done. Now, we're going to do a little exercise. When you hear this, you keep this phrase in the chamber. Now we're gonna try it, okay? That's impossible. You can't make that medicine. Oh my God, that's so difficult. You shouldn't do things that the doctor didn't order. You can't dismantle the racist patriarchy and make medicine free for everyone. That's impossible. I think we're gonna be okay. You want to create a collective? You should probably name it. You can name it whatever you want, but here's the system we used. Pick one from each category. Get a number, get a word, get another word. And then move on. Then the next part is you got to share it with the world. Because that's the thing, right? Anybody who ever knows, oh yeah, my guy figured out a fix for blah, 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 big, bug, and didn't post it, you have to share it with everyone. And I know some of you are saying, Michael, I know you work with world-class designers who did all of that for you. You didn't do it. Yeah, I know. They're so awesome. I'm so lucky. But guess what? This is yours too. We have a full branding guide. And because there's no Four Thieves Vinegar Collective anymore, and it's everybody's, this is yours. There are specific fonts, colors, and there's an entire repo with high-res pictures of everything we've ever used, and it's for you. There's a QR code. You're welcome. So brand your stuff. No reason not to. Four Thieves is just whatever you decide it is. Now, for every project that we've managed to make happen, there are dozens that didn't work. Here are a bunch of them. There are so many. There are so many. And these are just ridiculous. There are drops you can put in your ears that make you regrow your hearing. I need that desperately. There's a way that you can make a naloxone prodrug so that you could shoot it up along with an opiate, and it won't kick in until you stop breathing because it only deploys in hypoxic environments. And the list goes on. When I said earlier, I know you're thinking of a project, and you said, no, I can't think of a project. Well, let me tell you, there's a long list. Here's every project that we didn't finish for the past 10 years. It's a huge database. Free to download. It's a Zotero database. Every single one of the relevant papers is there, and you can search it. It's structured. Go nuts. You say you don't have anything to work on? Yeah, you do. There's a lot. A lot of things need attention. Poke through. You'll find something. You'll find something. And that'll stay up. And then this is the thing, right? It's like, God, we should really release something, but again, what if there's nothing? Is this enough? I'll tell you a little story. We had this project that some of you have heard about called the Tooth Fairy Project that was just like, it was so promising. It was something that you were going to be able to brush your teeth with once and never get another cavity for the rest of your life. And this piece of infrastructure was built with the sole purpose of being able to share this technology. Now, it just had to be rebuilt, so it's gonna, there's like a please be patient, and it'll be offline during DEF CON, but it'll be back on next week. But it's a set of forums. And it's there so that everybody can be in touch. If you're too introverted to make eye contact with somebody you haven't met yet, sort of nod, try and make friends, just log on. It's a Tor hidden service. Nobody knows who you are. Try and connect. It's easier when you have people around. This is a shortened URL that connects to the Onion service. I'll wait a minute because everybody's taking pictures. I'll try and pass this out around a couple other ways, but if you're taking pictures and you find it, please share it with everybody, because this is how we're gonna keep the band together once everything's over. And what happened to Tooth Fairy? Like, why didn't it work? It's such a long story, and if I only have 45 minutes, and I wish I could get into it. But we had a cool logo. I mean, isn't this guy cute? We had this too, which I thought was wonderful. And you know, it was one of those projects that was 2 weeks away for 8 years. And then this happened. Now, for those of you who know how to read this, over here where there's nothing, there's supposed to be nothing. And over here where these big blocks, there's supposed to be big blocks. Again, I can't get into how this goes, but I have covered it in past lectures, and anybody who wants to chat about it, find me afterwards at the bar, and I will happily regale you. How many people know about this project? Show of hands? Okay, cool. So, a handful. I'm glad. Because I only have 2 of them. So, who's done some biology and knows how to culture anaerobes? Come on, where are those hands? Ah. Now, I want to stress something. When I say I only have 2 plates, I mean I only have 2 plates. Not like I only brought 2 plates. These are the only 2 plates. So, somebody's got to step up and take this from me, or I can go throw it in the trash and it'll never go anywhere. All right, please, step up. You culture anaerobes? Yeah. Oh, I'm sorry, I'm going to pass it here. Thank you. And this is the important thing. It doesn't require us to perpetuate. Now, I might be able to get more. I'm hoping that that happens. Again, it's a long story. Find me on Polyester Path. Find these people on Polyester Path, and go trade it amongst yourself. And please, cure the most common infectious disease in humans, because it's right there. Now, this is the other thing, right? It's like in the past, I've tried so hard to call these executives, and it sometimes works. I have not told anybody what I'm about to do. Like, literally 0 people. And it's probably not going to work. So I'm not even going to say who I'm calling, again, because it's probably not going to work. And if it works, again, if I told anybody, they would have tried to talk me out of it. But I figure you came all this way into the desert for some entertainment, and it would be a real drag if I didn't at least make an attempt. If it doesn't work, I'll say who I was trying to call, but let's just try this.
Yeah?
Mr. Secretary, this is Dr. Michael Laufer from the Fourth East Vinegar Collective. I'd like to volunteer our services to help make America healthy again. Do you have a minute to chat? Hello? Well, that was a surprise. If anybody wants to start the GoFundMe for my bail, like right now. Okay, sorry, yeah, I didn't think that would work. I hope you all are entertained. Okay, moving on. Come on. Right, we should have something to release, right? We should. I might have one more thing. We've been talking about this for a long time. And I've only ever really shown the cover. Progress is slow, was slow for a long time, but it's real now. Our current word count is at 150,000. It's just over 400 pages. And I just got sort of a proof printed for me. And I'm pretty excited about it. It covers a lot of things. I'll show you the table of contents here. Kind of quickly, it's broken down into 5 parts. The first part concerns emergencies. The second part concerns acute things where you have some sort of something that came up, but then you have some things, yeah, we got a lot of pithy writers on the staff, yeah. So then you've got things that are long-term, and you have things that are chronic, and then there's a 5th section called graceful exits, which is dealing with death. And then we have a lot of appendices, a lot of referential things. And this is just about every trick we've ever come across that is useful. And that's why I went through a lot of this stuff earlier kind of quickly, because not only have I covered it in other talks, but it's been very well documented. In the end of the book, there is a bibliography, and it looks like this, where there'll be a little blurb by us, a picture of the book, information, and then an excerpt for most of them. And right now, we're hosting a reader on the site that will show you an excerpt. Now, we're not done, okay? We are eyeballs deep in editing. It's probably going to take another month or 2 to finish. But you can see some of it, including the table of contents and the bibliography, which is a couple hundred books. And the bibliography leaked, and some wonderful person somewhere packaged it into 3 torrents. I'll step out of the way. You can have every single one of these books that we use to research our book, and you can just download for free. Thank you, whoever the fuck you are. We are forever grateful. Round of applause for whoever that torrent person is. Again, also these QR codes are in the book at the end of the bibliography, so you should be able to use them if your picture didn't come out. Now, also on the site, because we don't have the book to release yet, we have these wonderful lists that you can sign up for. The first one is, of course, If you want to get it digitally, we will be hosting it in perpetuity for free, and you can get that. So if you put your email here, you'll get a notification with a download link when it's ready. If you'd like a physical book, you can sign up over here. And thirdly, if you want something super fancy and you want a fine-bound edition, you can sign up over here. And we hope you like it. Now, I have to mention this briefly. Currently, for the regular book, we have a deal with the print-on-demand service. If you notice over here, what we've done is we've diddled the price until our cut is nothing. So this is cost for us. That's ridiculous that it's $23. But the good news for us is that there's no money on the front end, no logistics. You click through, you pay them $23, and you get a copy of our book. Now that's fine, and we'll do it if needed. However, there is another option, which is we could get it printed for cheap if it looks like enough people would be interested. But that has to work volumetrically. So if you get all your friends to sign up, we might be able to print it for half that, less maybe. We'd be able to give a bunch away. It would be really great. But we're going to gauge it by how many people sign up on the list. So share it around, and if enough people do, then maybe we get lucky. I hear this a lot. And you know, sometimes I think about it, and I'm like, what do I do once everything's over? Like, it's like when the Grateful Dead broke up. Like, do I need to get a second pair of pants? I have to stop living in my car. And I don't quite know. But maybe if you all like the book, we can get around and do some more together. And the point of all of this is that we showed you it's possible. Everything is possible. There's nothing out there that you can't hijack. Any of you who are in security know that nothing is truly secure. And gosh, it's science. The whole point is that it's replicable. If it weren't, you wouldn't be able to do it. And so, being in America, I thought it apropos to utilize this wonderfully American phrase. Somewhere around there'll be stickers circulating like this. They glow in the dark. And I would like to add to this very American phrase a second related, very, very American phrase. So, it's yours now. It's up to you to do or fail. Let's keep it going. Keep each other healthy. Keep each other safe. I'm not taking questions, but you can buy me a drink downstairs. Thank you again all so much.
Thanks again, Mr. Loeffler. Thanks, everyone.
All right, folks, since we're going to do the questions outside of the hall here, that is it for the closing keynote. We do have the closing ceremony here in this same room in about 20 minutes. Hope to see you then. Thank you all for being part of B-Sides.